For decades, history said Vikings vanished at Newfoundland's edge in 1021. But in 2023, buried deep in the heart of Minnesota, scientists uncovered ancient genetic traces, Scandinavian markers where no one believed they could exist. The find didn't match migration timelines, and there are no Norse records placing Vikings anywhere near the American Midwest. If these DNA fragments are genuine, the story of North America's earliest European contact will have to be rewritten. So, how did this inland genetic signature appear, and could Vikings have really reached so far from the coast? In the spring of 2023, Dr. Emily Goodman, a molecular archaeologist at a Midwestern research lab, stared at a set of genetic sequences that seemed impossible. Her team had isolated 3 fragments of Y chromosome I1, an unmistakable marker tied almost exclusively to Scandinavian populations, recovered from lakebed sediment near Alexandria, Minnesota. The nearest confirmed Viking site, Meadows, lay over 1,500 kilometers to the northeast, separated by dense forests, countless rivers, and centuries of accepted history. For decades, the academic baseline, championed by scholars like Dr. Richard Hall, held that Viking presence in North America never extended beyond the Newfoundland coast. Goodman's findings landed like a thunderclap in a field where every major Norse discovery had been coastal, heavily scrutinized, and hotly debated. Word of the Minnesota sequences spread quickly through academic circles. Emails flew between labs in Oslo, Reykjavik, and Copenhagen. Geneticists pored over the data, searching for signs of contamination or error. Archaeologists revisited old maps, tracing possible water routes from Hudson Bay to the Great Lakes. The question at the heart of the storm was simple. How could Scandinavian genetic signatures, dated to the medieval period, appear so far inland, without a single written record, artifact, or saga to hint at such a journey? The mystery deepened. Historians accustomed to dismissing inland Viking legends as folklore were suddenly faced with a puzzle. The I1 haplotype fragments matched no known modern contamination profiles, and their stratigraphic context aligned with sediment layers from the 10th to 12th centuries. The implications were staggering. If the data held up, scholars would have to reconsider not only the scale of Viking exploration, but also the very timeline of European indigenous contact in North America. The discovery forced a pause. Some called for immediate replication, others demanded every step be checked for error, from core extraction to DNA sequencing. Yet the core fact remained. 3 ancient genetic signatures, buried deep in the American Midwest, refused to fit the story everyone thought they knew. The investigation now shifted from disbelief to scrutiny, as scientists scrambled to verify whether this genetic anomaly was a breakthrough or a mirage. Goodman's lab wasted no time putting the Minnesota sequences under the microscope, literally and figuratively. The first order of business was to confirm the age of the sediment layers where the DNA fragments had been found. Technicians examined the finely banded varves, each layer a record of a single year's deposition, counting back through the centuries until they reached the medieval period, sandwiched between 2 distinct flood markers. To cross-check, they sent samples to a radiocarbon dating facility, which returned calibrated dates hovering between 980 and 1120 CE. The sediment's depth matched the era when Norse explorers were active on the Atlantic coasts, but never this far inland. With chronology established, the focus shifted to the DNA itself. Ancient genetic material is fragile, easily overwhelmed by modern contamination. Goodman's team followed strict cleanroom protocols, full body suits, filtered air, and negative controls at every step. They sequenced the extracted DNA, searching for the distinctive C to T substitutions, a hallmark of ancient genetic material. The Minnesota fragments showed a damage rate of 15% at the sequence ends, a level consistent with DNA that had been buried for centuries, not decades. Contamination checks told a similar story. Less than 2% of the reads matched modern Scandinavian or North American reference genomes, far below the threshold that would suggest a recent source. To rule out error, Goodman collaborated with a second lab in Reykjavik. The Icelandic team received blind samples, unaware of their origin. Their results mirrored the original findings, detecting the same rare Y chromosome I1 fragments and similar patterns of molecular damage. Both labs used Bayesian analysis, a statistical approach that weighs the probability of authentic ancient DNA against the likelihood of contamination. The odds favored authenticity by a wide margin. As the evidence mounted, skeptics pressed for even more rigorous tests, independent replication, alternative contamination models, and deeper sequencing. Every new round of analysis seemed to reinforce the original conclusion. The genetic signatures were ancient, the sediment undisturbed, and the data robust enough to demand serious consideration. The debate was no longer about whether the signal was real, but how it could possibly exist in the heart of the continent. Elder Mika sits near the fire, her words measured and calm. She recalls an old tale from her grandmother's time, a story of strangers with square sails gliding silently up the river, their boats unlike any birch bark canoe. For generations, these stories held little weight outside her community, often dismissed as legend or misunderstood memory. Yet, in the same region, carved in stone and buried in a Minnesota field, the Kensington runestone has fueled a different kind of debate. Discovered in 1898, the runestone's runic inscription claims a Norse expedition reached this land in 1362. For over a century, it drew crowds and controversy, with some hailing it as proof of Viking presence and others calling it a clever hoax. Dr. Marcus Lund, a forensic archaeologist from Sweden, approaches the runestone with a different set of tools. He studies the grooves under high-powered microscopes, searching for the telltale signs of age. Modern steel blades leave marks that differ from medieval iron. Recent analyses reveal the inscription's edges are sharp, the tool marks consistent with 19th century chisels, and traces of modern cement cling to the stone's surface. For Lund, these details outweigh the romance of the legend. The runestone, he concludes, is almost certainly a product of its own time, not the Viking age. Meanwhile, other supposed Norse relics, such as axes, rivets, and shards, have failed metallurgical tests, showing alloys and manufacturing methods unknown before the 1800s. The material evidence, so far, stands on shaky ground. Still, Mika's stories persist, echoing through generations, offering a different kind of memory, one that cannot be measured by carbon dating or electron microscopes. Viking longships were engineering marvels, clinker-built with a shallow draft of 0.6 meters. This allowed them to slip through rivers and across lakes, even in water barely waist deep. In theory, a determined crew could have steered a longship from Hudson Bay, up the Nelson River, across Lake Winnipeg, and into the labyrinth of waterways reaching the Great Lakes. The total distance from the nearest Norse site to Minnesota spans nearly 2,000 kilometers, demanding as many as 15 portages around rapids and falls. Historical records show Vikings tackled similar journeys in Russia, hauling ships overland between rivers like the Dnieper and the Volga, sometimes for days at a time. Climate played a crucial role. The medieval warm period, from about 950 to 1250, brought higher water levels and less ice, briefly opening northern routes that are impassable today. For a narrow window, the Midwest's rivers and lakes may have been more navigable than at any point since. But the physical possibility of the journey is only one side of the equation. For historians and geneticists, the threshold for confirming Viking presence inland is exceptionally high. It is not enough to find a single artifact or a faint genetic marker. The gold standard demands a chain of evidence, stratified burials, securely dated artifacts, and independently replicated DNA results, all pointing to the same time and place. Without this convergence, even the most tantalizing clues remain just that, clues, not proof. The debate continues, balanced between what is technically possible and what can be proven beyond reasonable doubt. String.